Hi everyone, my name is Alina. I'm a developer advocate for GraalVM and Oracle Labs. And in this session today, we'll talk about how you can build fast and efficient Java microservices using GraalVM. So let's go. So the topic of this conference today is Java innovations, right? And I think GraalVM is a really great fit for it because there are so many ways how you can innovate in the Java ecosystem using GraalVM. The first one is that you can achieve really great performance for your Java JVM applications when switching to GraalVM because it is coming with a new highly optimizing GraalVM compiler that can really speed up your applications. One more great thing that you can do with GraalVM is use its native image utility, which allows you to produce native executables of your Java applications that will start really fast, need only a fraction of memory, and be great for cloud deployments. One more thing you can do with GraalVM is build and run polyglot applications, meaning applications that use more than one programming language. And this way you can really find and use the best tool for the job. And last but not least, GraalVM is also open source. Our development is happening on GitHub, so you can absolutely see what's happening there, what's coming next, and be a part of the project and the community. So a very quick recap of what GraalVM is for those of you who may be less familiar with it. GraalVM is a high-performance runtime, and it can execute all those languages that you see on top here and also work in a number of platforms and environments, the ones that you see below. So it can execute your normal Java JVM applications, and for this, it is working in context of OpenJDK or Oracle JDK. This way, you can easily switch to GraalVM and execute your Java applications as you normally would. It also comes with engines for languages like JavaScript and Ruby. And if you are into things like statistics, machine learning, or maybe data science, you could be interested in our R and Python implementations. Also, GraalVM comes with an LLVM runtime, so it can execute languages like C, C++. Talking about platforms, we mentioned OpenJDK. It also can work in a context of Node.js, or what is quite interesting in the context of database, such as, let's say, Oracle database. And last but not least, it can run in a standalone mode, in which it is the only runtime required to run your applications. So let's take a closer look at what GraalVM can offer for Java and specifically for microservices and what could be interesting in it for you. So the first thing to do with GraalVM, if you want to run your Java applications on it, is that you get to decide in which mode you want to run your Java applications on GraalVM. And this is quite interesting because in addition to normal JIT mode, the way you normally run your Java applications with Java command, right? You can also do this native image mode in which you first build your native image application and then you run it. And that is interesting that with GraalVM, you really get this option. You can decide whichever works for you or in each particular case. And in a second, we will talk about how exactly you make such decision. But the bottom line here, and one thing that I want you to take away from this slide, is that with GraalVM, you really get these options and you get to decide. Because this second native image mode is so exciting that sometimes people would only associate GraalVM with this native image mode. But the truth is that you can absolutely also run applications in JIT mode on GraalVM. And that's great because you really get these options if you are choosing GraalVM. So let's say we are interested in JIT mode, and what is it that we can get if we are running our Java applications on GraalVM in JIT mode? So one thing we can get is additional performance, which is coming from the GraalVM compiler. And what we are looking at here is a Renaissance benchmark suite. And you can see here on a wide range of workloads how running on GraalVM on Community Edition and on Enterprise Edition compares to running on OpenJDK. And if you take a closer look, you can notice that running on GraalVM gives you additional performance boosts in many of those workloads. So let's maybe see this for ourselves. And for that, we will run this sample Java Streams API application without GraalVM and then with GraalVM, and we will compare the performance. So let's go. So we will run this application, we will warm it up, and then we will measure performance. Let me just speed it up so we don't have to wait for the benchmark to run. Okay, so we are done running without GraalVM as top-tier compiler, and in this case, what we get is the average performance measured as nanoseconds per operation, and the average score is 284 nanoseconds per operation. Let's now run with GraalVM as top-tier compiler and see if we can do any better than that. Okay, fast forwarding again, and what we can see here is that now our average is 13.5 nanoseconds per operation, while before it was 284. So quite a performance boost, right? Obviously here I would have to say that each application is different, and the exact performance number that you can achieve for your application, the only way to find it out is to actually run a sample workload on GraalVM and measure it for yourself. But what I want to say here is that speedups like this are absolutely possible, and to see for yourself, the best way really is to run your own application and check how the performance will be different. Now, this is peak performance and how GraalVM can help you with that. But what if instead I'm rather interested in startup performance? So how much time it takes for my application to actually start, to do something useful, and what if also memory is one of the important things to me? For that, what GraalVM can offer you is this native image mode of operation, in which, as you said, we will take a Java application and we will compile it to a native executable that no longer requires a JVM to run. This way you can achieve these great startup characteristics. What is also interesting about this mode is that many Java frameworks are well integrated with the native image mode, so you can leverage the benefits of this mode of running your application and also use what these frameworks have to offer you. So what's happening under the hood when you're building a native executable of your Java application? When you run this command, what it does, it looks at your application starting from its main entry point, and it finds all the reachable code, and it's also running class initialization until the point where all the code is found, and it can optimize it and pack it as this native executable. And that's the way you build your native executable of a Java application. If you want to understand better how it's different and why it is different than running in JIT mode, here is a face-to-face comparison. And as you can notice, in terms of startup time, when you run your application in JIT mode, there is a lot of things that need to happen, right? You need time to load the JVM executable itself, load classes, start interpreting, start compiling, and then at some point you will run with optimized machine code. Now, how native image is different is that we've moved all those expensive operations to the image build time so that you can do them once, and then every single time you run your native executable, it runs really fast, because it already comes optimized and compiled. And similar also applies to the memory usage. So once again, native image can use very little memory because it only needs to keep memory around for the application executable and application data, and that's just it. This is where the memory savings are coming from. Now, how do you choose? So for example, I have my application, or I have one particular case when I'm hesitating between those two modes. How do I decide? Do I want to do GraalVM JIT, or do I want to go with GraalVM native image? So talking about performance and kind of performance dimensions, if you are more interested and more concerned in peak throughput and optimizing for latency, then go with GraalVM JIT, and it will be a great solution to optimize for those two performance dimensions. But if you would rather optimize for startup times, for memory usage, and also maybe packaging size, let's say you're working in resources constrained environments, then native image would be a good solution for you. So this is perhaps the easiest hint how you can decide between the two modes, but also we are working on making sure that with native image, you can really maximize all of those performance dimensions. Okay, let's say you take a look at GraalVM, you are interested, and now you want to create your first application. Where do you get started? One way to go would be, if you want to just get some apps and run them and see for yourself, would be to go to our GitHub repo where we store GraalVM demos, and there you can find demos that utilize different components of GraalVM, and you can run them and see for yourself how that works for you. That is one way to go. If you would rather create an application yourself, and especially if you want to leverage GraalVM native image, then going one with those Java frameworks perhaps would be a good way for you. I will talk about a couple of them. The first one is Micronaut. So this is a framework that really allows you to build Java microservices and serverless applications. And in fact, I want to show you this framework in practice. For that, let me run this application. It's a Micronaut application. And first, I will run this application in JIT mode. So you see that I'm starting it. Here I'm running it. And in a second, we'll see exactly what it does. So let me just go to the browser and open it. And basically, this is an application that responds to requests with a random conference name. Okay, so this time we will run it in a JIT mode. Let me shut it down, make sure that it's down. And now I will run the same application, only I already have it compiled over here as a native image. So now I will run it as a native image. We see that it's getting started, and let's see what it does. So we see that it functionally, it's the same. So it's the same application. It has the same behavior. But now as we pay attention to startup numbers, we would see that in native image mode, this application started in 0.2 seconds comparing to 2.2 the first time. So this is the difference the GraalVM native image makes for your application startup times. And this was a Micronaut application, the one we've seen before. But in fact, if you have a preference for another framework, you would observe similar performance improvements when running on GraalVM native image. So here we are looking at Helidon numbers, and you see that when we are comparing running their sample application on the JVM versus running on GraalVM native image, we are observing similar startup times improvements. Also, the same goes for Quarkus. You might have heard of this framework at other conferences. And what you can see here is that when they are running in the native image mode, comparing to running on JDK, and also comparing to running on what is so-called traditional cloud native stack, once again, GraalVM native image makes a big difference in terms of startup time improvements and also memory usage improvements. Now, what about Spring Boot? Can I run Spring Boot applications in this native image mode? The answer is yes, you can. You can go to GitHub and get there this integration project that we have with the Spring Boot team. It is still work in progress, But as you can see here on the chart on the table on the right, they already compiled some of their applications as GraalVM native images. And on this pet clinic example, we can see what kind of benefits you can get if running in this Spring Graal native mode. So for example, this pet clinic application now starts in just 0.1 seconds versus 2.6 as it was on the JDK. This is pretty great, and if you want to try it for yourself, you can get this project from GitHub. Here's the link, and it also comes with all these different demos that you can try for yourself, and you can run these Spring Boot applications as GraalVM native executables. Okay, so far so good. Let's say you have looked at GraalVM, you like it, you've tried some demos, and now you want to adopt it for your production applications or maybe your pet projects. So are there any helpful tips and resources that you can use to really help you in that journey? Yes, one great thing that I recommend you checking out is profile guided optimizations. So what this optimization does is that it allows you to collect profiles of your application, use this information at the native image build time, and then build a native executable that will be aware of this profile information, and that can this way really optimize for best peak performance. So if you want your native image to have the absolutely best possible peak performance, then definitely check out profile guide optimizations, and it will help you in that. Okay, and we've also seen that native images are quite tiny, right? But what if I want to reduce the binary size even more? Can I do that? Yes, you can. And for that, you can use a tool called UPX. We have a tutorial around it. You can play with different compression levels, and basically it will allow you to reduce the size of your native executable even more. What we've seen is many people have tried this already, and here are some of the results they're sharing. Like for example, here on the left, you can see that they took a Spring Boot application and the original native image of it was 66 megabytes, and it was possible to reduce it to 17 megabytes instead, which is pretty impressive. So if a binary size is important for you, then definitely check out this approach with UPX. And a couple more resources. So if you're already working with native images and maybe you want to configure them in terms of memory usage and GC options, or maybe if you want to understand better what is happening in terms of class initialization in your native executable, then check out these resources, and I'm hoping I can post these slides somewhere so you can have direct access to those links and resources. One more thing, so there are a lot of commands that can help you tune various aspects of your native image, and if you want to have them handy, we have this quick reference which you can save or print and keep around and have quick access to those most helpful options when you're working with GraalVM native image. Now, I want to talk a bit about GraalVM language ecosystem, because we are talking about microservices, right? And it might be the case that you want to implement some specific functionality in your microservice in some other language. You've seen this slide before, right? These are different languages that GraalVM supports, and in fact, there are even more. And what is great that GraalVM can run not only one of these languages we already established, right, but also run applications that are written in a couple of those languages. And GraalVM will give you interop between the languages out of the box, and it will also take care of optimizing your whole application. So let's take a closer look at some of those languages. One is, for example, JavaScript. If you're looking for a modern JavaScript implementation, then definitely check out our GraalJS implementation, because it's keeping up with the latest ECMAScript standards. And we are constantly testing against thousands and thousands of NPM modules to ensure that you can use all of those modules with your GraalJS implementation. What's interesting about GraalVM JavaScript is that you can also run it in a couple of different ways. The one that I would recommend is getting the whole GraalVM distribution and running it on GraalVM. But also, if you just want to give it a try, you can also use our GraalJS implementation from your stock JVM. One more way to go would be to use it from a native image that you build of your Java application. And let's say before trying GraalVM JavaScript, you want to also understand whether your favorite package is available and it's supported on GraalJS. So for that, you can just go to our website and find this compatibility tool and figure out the status of support for your preferred package. And if you are or have been a Nashorn user, we give you this tutorial that can allow you to migrate easily to GraalJS. And also what is quite interesting, we have this compatibility mode, which can make this transition for you even simpler. One interesting case of how you can use GraalJS that I want to share with you is, for example, this sample application that was using Scala on the server side and also had some React.js for client side. And when this application was migrated to GraalJS instead of Nashorn, as you can see on this chart below, to the left, which shows performance in a form of requests per second. After migrating to GraalJS, they observed significant performance improvements comparing to Nashorn. So if your situation is similar to this, definitely check out GraalJS. And I also want to mention Python. So GraalVM has a Python 3 implementation and an interesting use case of it. So this was implemented by the Oracle NetSuite team. And what they were developing is a new recommendation system for their e-commerce platform. And in recommendation systems, what you can really use is machine learning libraries to provide better recommendations, right? And as you know, many of those libraries are written in Python. But since their main application was written in Java, they really needed this way to bridge the gap between Java and Python and preferably have an easy way to run them together. And this is what they found in GraalVM. One more way how GraalVM was helpful in building this application is that there is this project developed by NVIDIA together with Oracle Labs, and it's called grCUDA. And what it does, it allows you to leverage GPUs from your GraalVM application so that you can get this additional performance boost. So in this case, it was not only possible to implement this on GraalVM, but also the final application was quite fast. And one more data science polyglot use case is this COVID trends visualization application, which is built, as you can see, in Java, JavaScript, R, and Python. And it's interesting how all of this language contribute to building this application, to getting data, processing, and outputting this information in such form. And in such polyglot applications, you can really utilize each language or each library to do just the right thing, such as, for example, here, R is used to visualize this helpful plot. Now, we've talked a lot about GraalVM. There are so many different components and so many different things that you can do with GraalVM. And I want to share with you a few examples of how some companies are already using GraalVM and what are the benefits that they are observing from switching to GraalVM. So one of more recent ones is Oracle Database. In its most recent release, 21C, it also introduced something called Multilingual Engine, which is in fact powered by GraalVM. And what it allows you to do is to use JavaScript right in your Oracle database, which is quite interesting. And it also shows how different components of GraalVM can be used to provide this additional capabilities and additional languages and be embedded in various environments, such as, for example, Oracle database. One more example is from Oracle Cloud Infrastructure. So if you remember, we were talking about this choice that you can make running your applications, Java applications in JIT mode or in native image mode. So this one is an illustration of running in JIT mode. And by moving some of the services to GraalVM, what this team observed and gained is improvements to peak performance, 10%, and also reducing garbage collection times. One more example is from Twitter. So Twitter actually are running their Scala microservices using the GraalVM compiler and also reporting great performance improvements. And this is actually something I want to mention additionally. So if you are a Java developer, or at least you work, if you're a Scala developer, or at least you work with Scala from time to time, definitely check out GraalVM because it can give you quite significant improvements to your application performance. Now, and one more example of a data science and also / polyglot application is from the Dutch National Police. And what is great here is that it allows this team to bridge this gap between application developers developing their application in Java or Scala and the data science team working with R, since this is their language of preference, right? And then they can run this whole workload on GraalVM because GraalVM supports both of those languages. And I want to mention an example of using GraalVM native image in production. So this is from Alibaba. And the way they adopted GraalVM native image was to build applications that will start really fast. And what they accomplished is 20x speed up of their application start time thanks to GraalVM native image. What's interesting here is that they've also, this is something battle tested. So they used native images during their sales festival when they have huge load on their system. And these native executable built with GraalVM proved themselves really well under such huge load. And a few words about project roadmap, also our community. So the latest release of GraalVM as of now is 21.0. You can get builds for Java 8 and for Java 11. And the next release of GraalVM will be available in April, so pretty soon. And if you want to plan ahead and see when the next release is coming, this information about the roadmap is available on graalvm.org. Talking about the latest release, one probably key feature that I want to mention is Java on Truffle. Also, this may be known to you by its code name, Espresso, so like coffee. And Java on Truffle is a JVM implementation written itself in Java and implemented using our Truffle language implementation framework. And it enables some interesting use cases, such as, for example, you can run your main Java application and then have a separate context in which you can run, for example, code of another Java version, let's say 11 in 8, or you can run in this isolated context some, let's say, less trusted code. Another way how you can use it is, for example, in native image, where Java on Truffle would bring these additional capabilities of dynamically executing code in native image. So this is definitely a very interesting project. If you want to learn more about it, check out our Medium blog. And also we are actively working on new features and new additions to Java on Truffle. So for that, check out our upcoming releases. Now, let's say you want to try GraalVM, and what are the options that you have? GraalVM comes in two editions. One is Community Edition, and the other one is Enterprise Edition. So Community Edition is open source, and for Enterprise Edition, you would need to get a license. But you can absolutely get both and use them for testing and evaluation and figure out which one works better for you. Also, talking about Enterprise Edition, it is available for Oracle Cloud customers and also Java SE customers for free. Now, to summarize how exactly you can innovate with GraalVM for Java, one is to get additional performance by simply switching to GraalVM. The other way is by building native executables of your Java application and using them, let's say, for cloud deployments. You can also build and run polyglot applications that utilize the best tool for the job in each particular case. And also GraalVM is open source, so you can join the community, join the project, see what happens, or contribute. Where you can get started, what are the good ways? So first, you can download GraalVM from GraalVM.org downloads. You can also follow updates. We are very active on Twitter. And if you need help or if you just want to connect with the community, you can do so in our Slack workspace, or you can send an email to this mailing list. Thank you. That is all that I had for the actual presentation. That is my name and that is my Twitter handle. Let's see if we have some questions. Okay, so can I run my existing application on GraalVM? Yes, you can. It's not like you have to create a brand new application. If you want to run something on GraalVM, you can absolutely run the application you already have. So in JIT mode, this will be super easy. In native image mode, what you would need to do is to build a native executable of your application, and it may or may not require some additional effort from your side. But it is absolutely possible to run your existing application on GraalVM. Yes. Let's see more. Does GraalVM support mobile platforms? So if you want to develop for mobile platforms, such as, for example, for iOS, what I would recommend you checking out is the work that the Gluon team are doing. I think their website is Gluon HQ or something like that. You can easily find it. And what basically they allow you to do is to write your application as in Java, as you normally would, right? And then compile it for those mobile platforms and also leverage GraalVM for that. So it's a really great way to kind of stay in the familiar Java ecosystem and also develop application for such platforms. I hope that covers your questions. The question, definitely check out their projects. Okay, what is the difference between community and enterprise GraalVM? Yes, so the difference is that with Enterprise Edition, you can get additional performance boost, even more than you can get with Community Edition. So what I would recommend you doing if you want to choose which edition is better for you is just to get both of them. So you can get Community Edition, and also Enterprise Edition is available for purposes like evaluation, testing, and so on. So basically, take both of them, run the application that you want to run, and see what the performance is like, and then decide which one is better for you. So there are no limitations for usage like that. Can I use JavaScript in native image? Yes, you can. So if your application is written in Java and it uses some JavaScript, you can still build a native image of such application. And the way it will work and it will run is the Java code will be compiled AUT ahead of time, while the JavaScript code will be dynamically executed when you run your application. But yes, it is possible to build such application. Can I use GraalVM native image for anything other than microservices? Yes, you can. So basically, any scenario in which you care about startup time or memory usage or even the packaging size. So any scenario like this would be a good solution to look at GraalVM native image. What we see happening in the community is, for example, they are often using native image to build CLI applications, because CLI applications is something where usually you want fast startup times and small binary size. So probably one more good way where you can use GraalVM native image is for building CLI applications. Okay, I think that was it.